Welcome back, folks. In today's video, we will be understanding about molality. In the previous video, we have discussed a little bit about molarity. Molality and molarity are the concentration terms used to express concentration of solutions. And concentration is nothing but amount of solute present in a given quantity of solution. By definition, we can understand this as number of moles of solute that's represented by NB dissolved in dissolved in 1 kg of solvent. Now we can relate it as small m is number of moles of solute, that's Nb, dissolved in mass of solvent in kgs. Now further breaking down this equation to Nb by, and this is mass of solvent in kgs, that means Wa in terms of kgs. In terms of grams, we can say molality is NB. Convert this to WB by MB, WB by MB, then multiply with 1000 divided by WA. This is moles per gram. Okay, this is moles, number of moles absolute per gram of solvent. So this one, the above one, was number of moles per kg, moles per kg. Got it? Now this equation signifies that volume is not involved in this case. Since molality does not involve volume, so it's the most preferred way to express concentration of a solution because it is temperature independent. Okay, since it only includes weights, okay, of solutes and solvents, so it's very convenient to express concentration and very accurately to express concentration in terms of molality rather than in molarity. In case of molarity, in the previous video, I have discussed that. So you can see in the last equation, there is volume included in the equation. So as the temperature increases, volume, yes, increases. Okay. Since volume increases, molarity will decrease. Okay. But this is not the case with molality. So it's a preferred one. Okay. So units of molality, I have already written some units like in terms of kg or in terms of gram. So units will be units of molality. Units of molality are moles per kg. Okay, so a smaller unit can be moles per gram. Okay, there's one more concentration term that's called mole fraction. That's very important as per the NEET and JEE examination is concerned, or as per the board exam is also concerned. It can be asked in your board exams as well. Let's break it down. Mole fraction. Mole fraction, since it is fraction, so that means it will be definitely in a fraction form. Mole fraction is denoted by x. It is a ratio of number of moles of one component over total number of moles present in a solution. Present in a solution. Now I'm talking about components of a solution. Okay, so in a binary solution, there are two components, for example, solute and solvent. Okay, so there may be a more number of components depending upon the number of solutes and number of solvents used to make a mixture. Now let's understand, in case of a binary solution, we have a solute and a solvent. So in that way, mole fraction can be discussed for solute and solvent separately. So mole fraction can be discussed individually for solute or can be discussed separately for solute and solvent. Mole fraction in case of solute is represented by xb, and mole fraction in case of solvent is represented by xa. Okay, so as per the definition, we can have xb equals to number of moles of, it's the ratio of number of moles of solute to total number of moles present in the solution. So if number of moles of solute can be represented by nb, and total number of moles of solution is number of moles of solute plus number of moles of solvent, na and nb. Okay, so same goes with the solvent part. We can write it as xa is equal to number of moles of solvent divided by total number of moles, that's solvent plus solute. Okay, now one more relation between xa and xp is if we add them up, or they will end up to unity. Okay, so let's understand that. Say for example, if I add up both of these like this, xa plus xb. Okay, so let's not jump to the solution earlier. So first let's sum up them. Xa stands for na divided by na plus nb, then it is summed up with nb divided by na plus nb. Look at the denominator in both the terms, it's same. Now xa plus xb, this is mole fraction of solute and solvent, will be equal to, take a common denominator, Na plus Nb, and sum up the numerators. This is Na plus Nb. So it ends up equal to 1. Got it? So we got a very important relationship. Xa plus Xb is equal to 1. Mark this one. So we can have a different value of Xa in terms of Xb. It's Xa is equal to 1 minus Xb. Just transpose this to over here. And we can also have Xb as 1 minus Xa. These are very important terms as per the numericals are concerned. So you can encounter these terms or these equations in solving numericals. So you must be very aware about the results. Okay then. So in the further discussion, we will understand about relation between, these are very, very important relations. As per NEET is concerned, or as per JEE examination is concerned. Okay. Now we will understand about relation between molality and mole fraction. Okay. I'm sorry. Now let's understand that we just solved some relations of mole fraction. That is, say for example, xb is equal to nb by na plus nb, and similarly xa will be na over na plus nb. Okay. Now take ratio of xb over xa. Okay, it will be nb divided by na plus nb, and then whole divided by na by na plus nb. So this will end up as na divided by na plus, oh sorry, it's nb, nb divided by na plus nb. Now what is na, what's nb? You must not forget about this. NB is number of moles of solute, and Na is number of moles of solvent. And then this will be reciprocal as Na plus Nb divided by Na. Now look carefully, some of the terms will cancel out each other. It will be this one and this one. Now we end up having Xb by Xa, the ratio equals to number of moles of solute divided by number of moles of solvent. Okay, now from here we can use a relationship, that is from mole concept, that number of moles of any substance will be given by a formula, that is Wb by Mb, given mass of that compound or the given mass of that uh, substance divided by its molecular mass. Say for example, there's a relationship that Nb will be equal to Wb given mass of solute divided by molecular mass of solute. Okay, so this one is given mass of solute, and this one is molecular mass absolute or molar mass absolute. In the same way you can do it for Na. Okay, in the same way you can do it for Na, that will be equal to Wa by Ma. Okay, and here the terms have their usual meanings. Let's use Wb by Mb and Wa by Ma in place of Nb and Na. Okay, so that we can have some expanded form of this equation. So it will be Xb by Xa is equal to Wb by Mb whole divided by Wa by Ma. Now it will be like this: Wb by Mb into Ma by Wa. Now look carefully to this equation. You may find some interesting relationship hidden in this equation. What is that? We say that Xb by Xa is equal to. Now, have you come across this equation in the previous video? Wb by Mb whole divided by Wa. This is molality in terms of kgs. This is molality. Okay. This is small m in terms of kgs. Then there is Ma. Okay. There's molecular mass of solvent. Now, this is in terms of kgs. Okay. So we can have molality in this way. So let me figure out this for you. Molality is Wb by Mb into 1 divided by Wa in kgs only. If we convert this into grams, I have already shown you that one. It's Wb by Mb into 1000 by Wa in that way. 1000 by Wa. It's in terms of grams. Okay. Now we are left with this one in the previous equation that I marked as 1. You can follow that. It's molality small m into mass of the solvent. Now, if you want to calculate molality in from this equation, you can have small m is equal to Xb divided by Xa into mass of solvent or molar mass of solvent. But we also have a relationship between Xa and Xb. So you can convert this relationship or this equation either in terms of Xb or in terms of Xa. Okay, so choice is yours. Okay, both will be correct. Now we know that Xa plus Xb is equal to 1. Now, in that way, xb can have value like 1 minus xa, isn't it? Now, change xb to 1 minus xa, or you can also change xa to 1 minus xb as well. Okay, so we can have two different relationships from here. Change this xb, okay, to 1 minus xa divided by xa into ma. This is another form of this relationship. Or we can also keep xb as it is and divided by change xa to 1 minus xb, 1 minus xb, and keep this in bracket, and then there is multiplied with ma. Okay, so you have two different relationships. One is here and one is here at the end. This one is in terms of xb, and this one is in terms of xa. Okay, so it depends upon what information is given to you in the question. So if it is given in the form of xa, use the first equation like this one. If it is given in the form of xb, then you can use this last equation. Okay, so we will be meeting soon. Please follow the channel and subscribe to my YouTube channel, as well as follow on the Facebook as well. Take care. Bye bye. See you in the next one.